Good morning, everybody. So, myself, Manmohan Panda from Electrical Department. Now, we will study the Ohm's Law. So, today topic is Ohm's Law. First, we have to find how the Ohm's Law is applied. Ohm's Law, the condition to apply the Ohm's Law. What is the condition to apply the Ohm's Law? Number one, the temperature of the conductor should remain constant. It is the main condition that temperature of the conductor should remain constant. Okay? If the temperature will vary, we cannot apply the Ohm's law. Number two, there should be potential difference. There should be potential difference. Number three, current must flow through the conductor. These are the three conditions in which Ohm's law is applied. These are the conditions in which the Ohm's law is applied. They will go for the law. Ohm's law states that the temperature of the conductor remaining constant temperature of the conductor remaining constant. This is the condition. Temperature of the conductor remaining constant. This is the condition. The potential difference applied across the ends of the conductor. The potential difference applied across the ends of the conductor is directly proportional to the current flowing through that conductor. The potential difference applied across the ends of the conductor is directly proportional to the current flowing through that conductor. Condition is the temperature of the conductor should remain constant. This is the Ohm's law. The Ohm's law gives the relationship between your potential difference and current. The Ohm's law gives the relationship between potential difference V and current I. It gives the relationship between potential difference V and current I. So what is the mathematical relationship? So potential difference V is directly proportional to the current I. Temperature should remain constant. The temperature of the conductor should remain constant. The potential difference is directly proportional to current flowing through the conductor. V is proportional to I, direct proportional to I. If V will increase, then I will increase. If V will decrease, then I will decrease. So we can write V is equal to Ri. R is the proportionality constant. Proportionality constant. R is the proportionality constant known as resistance of the conductor. Resistance of the conductor. Proportionality constant known as resistance of the conductor. The resistance is the property. Resistance, what is resistance? Resistance is the property. Resistance is the property of the conductor which opposes the flow of current through it. Resistance is the property of the conductor which opposes the flow of current through it. So it is the property of the conductor. Okay. So we find the formula that V is equal to Ri. So you will go for the graphical representation. Current is taken in the x-axis, potential difference is taken in the y-axis. Then the graph, the Ohm's law, the conductor obeying Ohm's law, the graph for that conductor is the linear gap which is passing through the origin. It's a linear graph. The current is linear. The any point in this graph gives the slope, and the slope of the graph gives the resistance. The slope of the V versus I graph gives the resistance of the conductor. In this graph we will find that the resistance is constant. Any point we can find the resistance. How we can find the resistance? You have to find the value of voltage, you have to find the value of current. Then by dividing, the resistance is R is equal to V by I, dividing the voltage, the potential difference with current, we can get the resistance of the conductor. So the resistance value is constant. Where it is constant? When the temperature is constant. When the temperature of the conductor is constant, we will get the constant value if the temperature of the conductor remains constant. Then we can get the constant slope. The slope is constant. Slope constant, which will give the resistance. We will give the resistance. Okay. So when the temperature will change, the resistance will change. When the temperature will change, the resistance will change. When the temperature will change, the resistance will change. With the increasing temperature, the resistance increases. With the decreasing temperature, the resistance decreases, but not proportionally. But not proportionally. It happens, but not proportionally. The resistance varying with temperature, it will not be proportional. Proportionally, it will not change. Okay? So with the increasing temperature, resistance increases, decreasing temperature, resistance decreases. In this case, Ohm's law is not obeyed. In this case, Ohm's law is not obeyed. So the conductor which does not obey Ohm's law, they are called non-ohmic conductor. The conductor is called non-ohmic conductor. The conductor is called non-ohmic conductor, and the conductor which obeys Ohm's law is called ohmic conductor. The conductor which obeys Ohm's law, it is called ohmic conductor. Okay. The conductor in which the Ohm's law is obeyed is called ohmic conductor. That means the temperature of the conductor will remain constant. Okay. So these are the main points which is related to Ohm's law. Then we go for if we are finding the graph for a non-ohmic conductor, for a non-ohmic conductor,